Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. The random variables x and y have joint probability function p of xy for x equal to 0, 1 and y equal to 0, 1, 2. Suppose 3 times p of 1, 1 is equal to p of 1, 2, and p of 1, 1 maximizes the variance of x, y. Calculate the probability that x or y is 0. So I don't know about you, but I find this problem just slightly confusing at first, because when you look at this, how is p of 1, 1 by itself maximizing the variance of xy when the variance of xy depends on other probabilities? But the issue is that the other relationships that we have between the probabilities that are given for this specific random variable xy work out this way, that every single other probability is a function of p of 1, 1. That there is an internal relationship between them. So you pick all of probabilities to maximize the variance of xy, but you can pick them by picking p of 1, 1. That's basically the story. And here's the solution. Consider a random variable z equal to xy. So we eliminate this confusion that we have x and y, but we're calculating the variance of xy. We just work with z. The possible values of the variable z are 0, 1, and 2, because x is 0 or 1 and y is 0, 1, or 2. So when you multiply them out, you can only get 0, 1, and 2. And let us write a, b, and c for the probabilities that z equals 0, 1, and 2 respectively. Note that, of course, a plus b plus c is 1. That's one of the relationships that make it so that we end up having everything depend on p of 1, 1. B is, by definition, p of 1, 1, because how else do you get 1 by multiplying 0, 1 by 0, 1, or 2. You have to multiply 1 by 1. So that's how you get B. The probability of x being 1 and y being 1 is the same as probability that z is 1. And then c is the probability that z is 2, but you can only get 2 by multiplying the x value of 1 by the y value of 2. And this results in 3b being equal to 1 minus a minus b, because we are told that c is equal to 3 times b, and c is also equal to 1 minus a minus b. So 3b must be equal to 1 minus a minus b, and therefore a is 1 minus 4b. And of course c is equal to 3b. And we are supposed to kind of express everything in terms of p of 1, 1, and then maximize the variance. Well, p of 1, 1 is b, so let's just work with b. So we then calculate e of z, which is 0 times a plus 1 times b plus 2 times c, is b plus 2c, which is b plus 2 times 3b, so 7b. And e of z squared is b plus 4c, which is b plus 4 times 3b, so that's 13b. And the variance of z is e of z squared minus the mean of z squared, so 13b minus 49b squared. And we're supposed to maximize this. And of course, this is a quadratic function. The graph is a parabola, but upside down because of the negative coefficient in front of b squared. And the value of b, which maximizes the variance of z, is the vertex of that parabola, the point that corresponds to the vertex of the parabola. So that's b equal to minus the coefficient of b by itself without higher power, and b is there, so minus negative 13 over 2 times the coefficient in front of the square of the variable, so 2 times negative 49. That's 13 over 98. Now you could take the derivative of this variance with respect to b, establish when it's 0, that would be the point, and then take the second derivative to see that it's a maximum. But you know that it's a maximum because you can see that there's a negative coefficient in front of b squared, maximum with respect to possible values of b. The probability that x or y is 0 is the same as the probability that as z is 0. We're supposed to find the probability that x or y is 0. Well, that's the same again as the probability that z is 0. And by definition, that's a. And a is 1 minus 4b. So that's 1 minus 4 times 13 over 98, which is 1 minus 26 over 49. And that's 23 over 49. And that's answer C. Please remember, this is copyrighted material. The problem itself belongs to a Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.